Hello, ladies and gentlemen. Mr. Donnie here again with some chemistry. Today we are looking at stoichiometry. I like fun saying that word, stoichiometry. So the objective is to be able to use balanced chemical equations to determine how much product is made or how much reactant is required for a given reaction. So first, I like to start with an analogy because I think you guys will get it and it'll help. All right. So my recipe for delicious bacon double cheeseburgers is one hamburger bun, two slices of cheese, two hamburger patties, and four strips of bacon. You gotta load it up with bacon. So quick question. Well, based on this recipe, if I have five bacon double cheeseburgers, how many buns do I have? Well, let me go back. I have one hamburger bun for each. So I must have five because I have five bacon double cheeseburgers. How many hamburger patties do I have? Well, there's two on each one, so I got a total of 10. How many slices of cheese do I have? Let me go back. Well, there's two slices of cheese for each bacon double cheeseburger. I got five. So that will give me a total of 10. Now, how many strips of bacon do I have? Well, like I said, you load it up with bacon, four slices for each burger. There's five burgers, so I got 20 slices of bacon. Right? And what we have just done is some stoichiometry, believe it or not. That's all we've done. All right. So, question: how many bacon double cheeseburgers can I make if I start with one bun, two patties, two slices of cheese, and four strips of bacon? Hopefully, you realize that's a recipe for just one bacon double cheeseburger. The next one, if I have twice as much stuff, I have two buns, four patties, four cheeses, and eight strips of bacon, I can make two. If I have a dozen of each of these things, I have a dozen buns, 2 dozen patties, 2 dozen slices of cheese, and 4 dozen strips of bacon, I can make 1 dozen. All right. Now I'm going to make it a little weird. If you had 1 moles, remember moles, if I had a mole of buns, 2 moles of patties, 2 moles of slices of cheese, and 4 moles of strips of bacon, how much bacon double cheeseburgers can I make? I would be able to make 1 mole of bacon double cheeseburgers, which would be a lot of cheeseburgers. Like you could probably feed and then kill of heart attacks like all of New York State with a mole of cheeseburgers, if not more than that. Somebody do the math, extra credit. All right, so basically stoichiometry is just using what we just did, but applying it to chemical equations. All right, so you got to remember that a balanced chemical equation is a recipe just like my recipe for bacon double cheeseburgers, but for making the products that are in the equation. So let's just take a look. So here's an example. I have a balanced chemical equation for this reaction. It says 1 mole of Br plus 2 moles of NaI will give me 2 NaBr and 1 I2. So the ratio is these coefficients, and it's telling us how many moles of each we need. If I have 1 mole of Br2 and 2 moles of NaI, I can make 2 moles of NaBr and 1 mole of I2. It's always that same ratio once we got the balanced equation. So question being, how many moles of Br2 are needed to react with 6 moles of NaI? So it's saying if I had 6 moles of this stuff, how much Br2 would I need? So some problem solving skills with this kind of problem. First thing you should do is circle the compounds that they're talking about. And I always do, I circle right in the problem, Br2, Br2. And then I usually pick a different means of circling, like I'll box it, and I'll box the other one, just so that when I'm going back to the problem, it's easy for me to differentiate between the two. So now we got to set up a ratio for the number of moles based on the chemical equation. And I write that right underneath. So it says 1 Br2, right? That blank is a 1. It needs 2 NaI. So now I set up the ratio between what the equation says and what's given in the problem. So this 6 moles, well, is that 6 moles of NaI or 6 moles of Br2? Well, it's 6 moles of NaI. So I box that one, so I know I got to put it on the box size. All right, well, it's 6 right here. That's the box size. That's 6 moles of NaI, so it's on the 2 side. I'm trying to solve for Br2. So now I just can cross multiply and divide. I get 2x equals 6 moles. So now I just divide each side by 2, and you get x equals 3 moles. So that's my answer. That's how many moles of Br2 I would need to react with 6 moles of NaI. Now you may have been able to look at this ratio 1 to 2 and just been like, oh, well, that's easy. If you can see that relationship right off the bat, 1 is to 2 as blank is to 6, and just know it's 3. Good for you, awesome. Please still show your work. All right, if you don't show work, I can't give you credit. Yep. So sig figs. So going back to that problem, we solved for moles and we found 3 moles. But sig figs, how do we figure out sig figs? You look at the problem. Whatever is given in the problem is how many sig figs you want in your final answer. You may be asking, well, what about those 1 to 2 ratio, Mr. Donahue? Isn't that only 1 sig fig? No, because that is a counting number. It's not a measured number. It's an exact number. We counted that as exactly 1. So that's why you can ignore these for sig figs and you just look to the problem. Some more examples. How many moles of I2 are produced when 5 moles of NaBr are made? So I'm going to box the 5 as well because I know it goes with NaBr. So I'm going to look down to my problem and I'm going to go circle I2 and box NaBr. So these are the things that they're talking about. Now I'm going to set up my ratio. I'm going to look at the coefficients. It's 2 for NaBr and it's 1 for I2. So that's my ratio. For every 2 NaBr, I need 1 I2. And this 5 that they're saying, 5 moles of NaBr, well, let me put that 5 on the NaBr side. So 5.00 is 2x. So now I cross multiply and divide, and I get x equals 2.50 moles. Again, notice how I used 1, 2, 3 sig figs because the number that they gave me in the problem had 3 sig figs. Another example. How many moles of N2, so let me find what they're talking about, are produced when 30 moles of NH3 are decomposed? All right, here's that stuff. So now set up my ratio. This is what they're talking about. The ratio between the two is 2 to 1. It's not always 2 to 1, just the examples that I picked happen to be 2 to 1 pretty commonly. So now, what does this 30 belong to? This 30 moles, it's of NH3, so I got to put the 30 on the NH3 side, is 2x. So now I can cross multiply and divide, and I get x equals 15 with 3 sig figs, 15.0 moles. So that's how you solve those problems. See you in class. Bring questions. All right, math. I know people struggle with it. Practice, practice, practice. Bring some questions. See you then.